Okay, in this example, we are going to look at how to write a polynomial with the given zeros. Here our zeros are -2, 3, and 5, and I just want to remind you what it means to have a zero, graphically speaking, that is. If we have zeros, then that means along the x-axis at -2, at 3, and at 5, our function must intercept the x-axis. Now, it very well may pass all the way through the x-axis, or it could just touch and turn around. Regardless of the fact, we are going to go ahead and write a polynomial with the given zeros. The first thing I want to point out is that we know x equals -2. We know x equals 3. And we also know that x equals 5. I don't know if these colored pencils are going to work out for me, so I'm going to pause. Okay, I'm grabbing a different writing utensil and I'm going to trace over this. So we know x equals -2, x equals 5, and x equals 5. Now, these are zeros, so originally we had factors. We had our linear binomial factors that were then solved for x in order to find these x-intercepts or zeros or solutions or roots of our problem. Anyhow, so I can, as you see, set each of these equations equal to 0. And then I'm going to express each of these as binomial factors of our polynomial. Now, to actually write the polynomial here with these given zeros, this is the exact process we would take every single time. I need to multiply these factors together. X times x is x squared. X times -3 is -3x. 2 times x is 2x, and 2 times -3 is -6. I'm not going to worry about that last binomial factor until I'm done simplifying those first two binomials that have been multiplied together. I have two linear terms that can be combined, -3x and +2x. When I combine those terms, this is the result. And now I'm ready to continue multiplying. I am going to do some right-hand distribution, and I'm going to distribute this x across this trinomial here. So x times x squared is x cubed. X times -x is -x squared. X times -6 is -6x. And now I need to distribute this -5 across the trinomial. So -5 times x squared is -5x squared. -5 times -x is +5x. -5 times -6 is +30. Now I need to combine any like terms. I have a cubic term here. There's just one x cubed, and there are no other cubic terms for me to combine this with, so I just have that 1x cubed. Next, I have my quadratic terms. Those are the terms that are raised to the power of 2. -x squared and -5x squared. These are the only quadratic terms I have. When I combine them, I have -6x squared. Next, I have my linear terms that need to be combined. Linear terms are when our variable is raised to the power of 1. So -6x and +5x. When I combine these two linear terms, I have -1x. And last but not least, our constant. There is our constant. So this is just one of the infinite polynomials that could have these zeros. Now, if you're wondering what I mean by infinite, I could have changed the exponents for these binomial factors. For example, this 0, maybe it could have had a multiplicity of 3, or the exponent of 3. Maybe this second 0 I have here, it could have been raised to the power of 4. Maybe this third one could have been raised to the power of 2. If you were to change those multiplicities of your linear binomial factors, then you would end up with a different end result. Now, I'm not going to do that here because that would drag out this problem. But one thing I am going to do is I'm going to check my work. So here is my final answer of what I believe to be a polynomial with these given zeros. Using my graphing calculator, I can type in that polynomial that I created. So I've got x cubed minus 6x squared minus x plus 30. I'm going to graph this, and so that way I can actually analyze my zeros. If I did my calculations correct, then you will see our function intercepts the x-axis at -2, 3, and 5. And seeing here on the screen, that's exactly what happened. So this does check out. Now let's look at a different type of problem. Let's look at writing a polynomial function that could be represented by a given graph. So this is a little bit different, and forgive my graphing skills. I did this free-handed. It's a little rough. But anyhow, looking at this graph, I want to go ahead and first list out my zeros. And again, my zeros are where my function intercept the x-axis. They are the x-intercepts, the solutions, the roots, the zeros. All four of those things describe the exact same spot graphically. And again, that is where my function touches the x-axis. Anyhow, I see that I have a 0 here at -4. I have another 0 here at -2. And then I've got a third 0 at 1. So I'm going to list those out. So x equals -4, x equals -2, and last but not least, x equals 1. Now to build my binomial linear factors, I am going to set each of these equations equal to 0. So adding 4 to both sides, we get that x plus 4 equals 0. Adding 2 to both sides of this equation, we get that x plus 2 equals 0. And last but not least, subtracting 1 from both sides of the equation here, we find that x minus 1 equals 0. Now the left-hand side of the equation, those are our binomial linear factors. So let's go ahead and write this as a polynomial in factored form. Okay, now that I have that, I'm going to go ahead and repeat the process that we did with the previous example. I am going to distribute. So x times x is x squared. X times 2 is positive 2x. 4 times x is positive 4x, and positive 4 times positive 2 is 8. There's nothing else for me to distribute amongst these first two groups. I need to combine any like terms within this first group, and I have two linear terms that can be combined. Again, a linear term is when our variable is raised to the power of 1. So we have 2x to the first power and 4x to the first power. In total, we have 6x to the first power. So let's go ahead and combine those like terms. And we are going to repeat the process of multiplying here. So I'm going to go ahead and do some right-hand distribution this time. I'm going to take this x and I'm going to multiply it by x squared. I'm going to take this x and I'm going to multiply it by 6x. And last but not least, I'm going to take this x and multiply it by positive 8. Now I am done distributing this x. I'm going to move on to -1. -1 times x squared. -1 times 6x, -1 times 8. And then from here, I need to step back and see what terms are like terms so I can combine them and simplify this. I have one cubic term here. There are no other cubic terms, so I only have this 1x cubed. I have two quadratic terms. I have positive 6x squared and negative x squared. When I combine those two quadratic terms, I have 5x squared. I have two linear terms, positive 8x to the first power and negative 6x to the first power. When I combine those two, I end up with positive 2x. And last but not least, I have my constant. So here is just a polynomial that could have these given zeros that were graphed for us. And again, I'm going to go ahead and type it into my calculator to make sure that it is correct. Okay, so I did go ahead and type that function into my calculator. I'm going to press graph. And you can see that my zeros match what was given in this graph at the start of the problem.